Hello everyone. Welcome to the topic Millman's theorem. So we will directly step into the statement. Now, this is the statement given by Millman where in any network, if the voltage sources in series with their internal resistance are in parallel, then those sources can be replaced by a single voltage source in series with R dash. You can have a more clear understanding by looking into this circuit representation. See, look at this left-hand side circuit. You can see there are more than one voltage sources along with their resistance connected in parallel. See, this voltage V1 and R1 is a combo. This and this are in series. Similarly, each voltage source and their internal resistance are in parallel. So in case if there is a circuit where you have this voltage and resistance combo connected in parallel, so Millman gives the way to combine all these voltage sources into a single voltage source, as well as you can combine all the internal resistance into a single resistance called R dash. Of course, you cannot directly add it, but he has given a formula to find out the equivalent resistance and the equivalent voltage, which is given here. So you can find out the expression for the V dash, which is nothing but V1 G1 plus V2 G2, etc., divided by G1 plus G2, etc. This G is nothing but conductance, that is reciprocal of resistance. So G equal to 1 by R. And equivalent resistance R dash is given by 1 divided by G1, G2, etc. Summation of G1, G2, etc. Now, in the same way, you can also try reducing a number of current sources in series into a single current source along with their conductance. Millman has also given formula for that. So look at this diagram. So this is nothing but a circuit consisting of more number of current sources connected in series, and G1, G2, G3, etc. are there concerning or corresponding conductances. So you can combine all these current sources into I dash and combine all these conductances into G dash. And this is the formula to find out the equivalent I and equivalent G. So we will understand this concept by taking one example. This is an example given to you where you are asked to calculate the current I using Millman's theorem. So the current I is marked with the middle branch, that is 3 ohms. So you have to find out what is the current flowing through 3 ohms. If it is not given as Millman's theorem, you can directly use your mesh analysis or nodal analysis or any kind of method, whichever is okay for you. But here we want to apply Millman's theorem. So we are going to learn how to apply Millman's theorem. So we will take the circuit and we will apply Millman's theorem. Okay. So where does Millman's theorem comes into picture? Only if you have two or more voltage sources in parallel, or two or more current sources in parallel. So if you look at this circuit diagram, you can see these voltage and resistance and this voltage and resistance are in parallel, right? So it is clear that in this circuit, this voltage source along with this resistance, okay, and this voltage source along with this resistance are both in parallel. So these two are in parallel. These two are in parallel. So what we are going to is we are going to combine these two and we are going to represent in the form of a single voltage source along with a single resistance, right? So so here we are going to represent this as V1. If you take this as V1, then the resistance is R1. If you take this as V2 and the resistance is R2. Okay, and G is nothing but the conductance. So conductance is nothing but G is equal to reciprocal of resistance. Okay, so now we have a direct formula to find out the equivalent voltage source. Just let us substitute here. So what will you get? It is equal to, here it is V1 is 10 and G1 will be, it is 1 by R, so it is 1 divided by 2, plus V2 is, it is 20, and G2 is 1 divided by 5. Okay, the whole divided by 1 by 2 plus 1 by 5. Okay, so when you substitute the values and when you solve it, you'll get the voltage value as 12.86 volts. Okay, right. So next step is you have to find out the equivalent resistance. It is a directly applicable one formula, 1 divided by G1 plus G2. This is R1 and this is R2. So G1 means reciprocal. So 1 divided by 1 plus 2, sorry, 1 by 2 plus 1 by 5. Okay. So you will be getting the resistance as 1 divided by 43 ohms. Okay, this is the equivalent resistance value. Now we have got the simplified voltage and resistance. So you can look at it into this picture. So we have combined this and this. Okay, we have joined these two parallel voltage and resistance, and then we are representing it as a single voltage source and a single resistance, that is R dash. Okay, yes. Now we have found out the formula. We have found the value of V dash is 12.86. So this is 12.86. Okay, and R dash is nothing but 1.43 ohm. So 1.43 ohms. Okay, now you're asked to find out the value of current I. So what is I is equal to? It is 12.86 divided by, it is 1.43 plus 3. Again, when you simplify this, you will be getting the answer I is equal to 2.9 amps. So the circuit has been now simplified. Now, in this example, we have taken a simple circuit. So it might look like why should we spend this much of steps to find out this current? Because you can directly solve it by writing to mesh equation, and if you solve it, you get the current equation. Yes, but this is for an easy understanding. We have taken this simple circuit, but actually, this theorem and all will be more useful when you really apply it for the complex circuit. Okay, fine. Thank you.